and composition. So first of all, looking at operations of functions, we're letting f and g represent two functions, and we're trying to create a new function h by performing the four basic operations. So I would recommend writing this chart down somewhere in your notes. So on the left side here, we have our four basic operations: addition, subtraction, multiplication, and division. And in the middle, we have the basic definition, which just provides the outline for how each of these operations work within our functions. And then on the right side, we have an example. So starting with addition, it is defined as our new function h of x equals f of x plus g of x. So for our example here, we are trying to create our new function h of x, and we are going to do so by taking f of x, which is 5x, plus g of x, which is x plus 2. Okay, now we're just going to combine like terms. So we know that h of x equals 5x plus x, which is 6x plus 2. Okay, subtraction, very similar process. So creating h of x, we are going to take f of x, which is 5x, minus g of x, which is x plus 2. So this is where your parentheses will come in handy, because essentially we are distributing a -1 to both of these terms in g of x. But anyways, f of x minus x is going to give us 4x. -1 times 2 gives us -2. Write these equal signs here. Next, we have multiplication. So we are going to take, well, we're going to create h of x, which equals f of x, which is 5x, times h of x, which is x plus 2. So in this case, we're going to distribute. We have h of x equals 5x times x, which is 5x squared, then 5x times 2, which gives me 10x. Okay, finally division. So for division, creating h of x, we are going to take f of x, which is 5x, divided by g of x, which is x plus 2. And in this case here, we actually can't reduce anything. So that's our simplest form for division of our functions. Okay, so those are just the basic examples for all four types of operation. Let's scroll down here and look at just a few more in a different scenario. So this is what problems will look like on a tester quiz for composition and function operations. So right here, we are given that f of x equals x squared plus 3x minus 5, and g of x equals 2x squared plus x minus 9. So we're going to perform the following operations. So I know they're all written in slightly different forms between the two different definitions, but number one here is showing addition. So this just means that we're taking f of x plus g of x. So let's write that out. So I've got f of x, which is x squared, plus 3x minus 5. And we're going to add that to g of x, which is 2x squared, plus x minus 9. So now all we need to do is combine like terms. So x squared plus 2x squared gives us 3x squared. 3x plus x gives us 4x. -5 plus -9 gives us -14. And that right there is our simplest form. Secondly, in number 3 here, we are taking g of x minus f of x. So make sure you guys write this in the correct order. So first we have g of x, which is 2x squared plus x minus 9. And we're going to subtract f of x from it. So minus x squared plus 3x minus 5. Okay, so now let's combine our like terms. So 2x squared minus x squared is going to just give me x squared. X minus 3x gives me negative 2x. And then negative 9 minus negative 5 is the same as saying negative 9 plus 5, which is just a negative 4. Okay? And finally, sticking with just the ones on the left side, we'll save the right side for class. We have f of x divided by g of x. So f of x is x squared plus 3x minus 5 divided by g of x, which is 2x squared plus x minus 9. And once again, in this case, there's nothing we can do to simplify this. So we'll just leave it. Okay, we're going to skip the ones on the right side. Please give them a try on your own, and we will go over those to start class. All right, so next off, we have composition of functions. So composition of functions is the process of combining two or more functions to create a new function. Okay, it is the process where we will substitute an entire function into another. So there's two ways to write composition. The first one is represented like this, where we are composing the function g with a function f of x. This can also be represented as g of f of x. That's how we read it. So to evaluate g of f of x, we're going to find the f of x value, the output, and we are going to put that value into g of x. So the output of f of x becomes the input of g of x. If I was to write something down if I was you guys, I'd probably just write this last section right here. So let's give this a look. So in this case, they give us different inputs and outputs as a set for both f and g. We are going to evaluate the given function. So right here, we have f of g of 2 in this case. So the first thing I would find out is, what does g of 2 give us? Because that output is going to be the input for f of x. So g of 2, when I input 2, so when 2 is my input value, I get 3 as my output. Okay? Now that output 3 becomes the input for f of x. So I have f of 3, which gives me, f of 3 will give me 4, which is my final answer in this case. Okay? So this is one way to write it. The other way is like this way in number 8, where we have g of f of 3. So start in your very inside parentheses. First of all, let's find what f of 3 equals. When I input 3 into f, I get 4 as an output. Okay, that output's going to become my input. So now I have g of 4, which is going to give me 3. Okay, hopefully you guys are kind of able to see what I mean by that process. Okay, please try the other two on your own. So let's just go over one or two examples of composition of functions here. So this is more what you guys are going to see for examples. So in number 11 here, I have h of g of 2. So the first thing I want to evaluate is g of 2. So I'm going to take 2 and I'm going to substitute it as my input into g of x. So I've got 2 squared minus 3 times 2 plus 6. Simplifying this, I've got 4 minus 6 plus 6, which finally, that's just going to give me 4. So g of 2 is 4. Now I need to figure out what h of 4 equals, because this now becomes my input. So now substitute that into h of x. So I've got 4 times 4 minus 1 gives me 16 minus 1, which is just going to end up giving me 15. Okay, so hopefully between these and those last two that I completed, that you guys have somewhat of an idea of how to do number 12 here. I do want to take a look at one more, and maybe we're going to choose to go over 13 actually. Well, actually, I'll do 14. So in 14, I have g of h of x, so just the opposite of what we just solved. But this time, instead of giving me a value, we are just evaluating for x. So the first thing I want to list is what's h of x? H of x equals, and exactly what we're given, 4x minus 1. So now I'm going to take this input value, or output value, sorry, and that's going to become my input for g of x. So I've got g of 4x minus 1. Okay, we're going to evaluate that just as substitution. So anywhere I see x, I'm going to substitute 4x minus 1. So I've got 4x minus 1 squared minus 3 times 4x minus 1 plus 6. Now we just need to simplify. So for this first one here, I'm going to need a FOIL. In my second term here, I can just distribute. So negative 12x plus 3, and then plus 6. So now foiling, I'm going to skip the combining like terms process with the FOIL. This is going to give me 16x squared minus 8x plus 1. And now I'm just going to combine like terms. So I've just got 16x squared minus 20x plus 10. And that's going to be my final answer there. So when you are evaluating a composition of functions of just x, you are most likely going to get a more complex function than what you originally started with, but that is just fine. Okay? So hopefully this helped give you a decent idea of composition and operations of functions. Please try the other ones on your own. Practice is really going to help with this kind of a concept. All right, thanks for watching.